Hi everyone, today we will study special products and we will discuss the sum and difference of two terms, and another form of special product is the square of binomial. First, let us define special products. Special products are simply special cases of multiplying certain types of polynomials together. Let's begin with our first special product, and that is the sum and difference of two terms. And the pattern is like this. We have x plus y multiplied by the x minus y. So the x, or the first term of the first group, is the same with the first term of the second group. The second term of the first group is the same with the second term of the second group. The only difference here is the sign. This is plus, the other is minus. Or sometimes we can put the minus sign here and the plus sign on the second group. So according to the rule, the answer here is the first term, that is x, we will put a square and then minus, and that is always minus. The second term, y, will be squared. Let's have a quick multiplication for this x plus y times x minus y. So we have to multiply x by x, we will get the x squared. We multiply x by the negative y, we will get this negative xy. The y multiplied to x, we will get the yx, or we can put xy to show that the similarity with the other term here. So we'll put xy, and y multiplied by negative y, we will get the negative y square. Then we can see that we can cancel the negative xy and the positive xy here. So copying the remaining terms, x squared and then minus y squared. And we can see that this product is the same with our formula here. So now we are ready to take some examples. Example 1, x plus 5 multiplied by x minus 5. So we will use our formula. We will take the first term x and then we will square that. Then minus, we will get the second term 5 and we will square that. And then we will just simplify each term to be x squared minus 25. So this is our final answer. Let's have example 2, 2x minus 10 times 2x plus 10. So this time the negative sign comes first and the plus sign is in the second polynomial. So the same idea, we can use this formula. So what we'll do, the 2x, that is the first term, we will put it here and square that, and then minus the 10, the second term, put it here and then square that, and we will simplify each term. So the 2x all raised to 2 becomes 4x squared, then minus the 10 squared is 100. So this is our final answer. Example 3, 4x plus 7y squared multiplied by 4x minus 7y squared. The first term 4x is squared, then minus the 7y squared is again squared. So we simplify 4x all raised to 2, it becomes 16x squared, and then minus the 7y squared is raised to 2, so it becomes 49y raised to 4. So this is our final answer. Let's go now to the square of binomial, and this is of the form, the first part is x plus y raised to 2. So this is the sum of two terms and raised to 2. In the book, we write the answer it to be x squared plus 2xy plus y squared. It means to say, if we're going to square a binomial or the sum of two terms, we expect three terms in the final answer. So let us examine one by one. The first term here is simply the square of this x. So you see here it is x squared. The middle term, the constant 2 will always be there. And then the xy here is actually the product of these two terms, x times y. So this is xy. And the y square here is the square of this y, the second term of our binomial. So that is y squared. So again, when we square a binomial, the answer will be three terms, and this answer is x squared plus 2xy plus y squared. So let's have a quick multiplication of this x plus y all raised to 2, this square of binomial here. So what we'll do, first, we are going to expand the exponent. The power 2 simply means we have x plus y times x plus y. And then we will do the long method of multiplication. One by one, we will multiply the x with the x. We will get x squared. X multiplied by y, we will get the xy. And then the y multiplied to x, we will get the yx, or we can write it also as xy. And the y multiplied by y, we will get the y squared. There are like terms that we can combine. xy, another xy, we'll put 2xy. So the final answer, x squared plus 2xy plus y squared. We can see that this product here is the same with our special product on top here. It means to say, we can now use this formula in some of our examples. So example 1, the a plus 3 is raised to 2. So in our answer, we expect three terms represented by these three blanks. So the first is the a is squared. The middle term, the a and the 3 are multiplied here with the 2 constant. We will not forget the 2. And that is for the middle term. And the last blank is for the 3 to be squared here. And then we will simplify each term. So the a raised to 2 becomes a squared. The middle term, 2 times a times 3 becomes 6a. And the 3 squared is 9. So the final answer is a squared plus 6a plus 9. Example 2, 5x plus 2y all raised to 2. So for our three terms, directly I put here. So the 5x comes from the first term and it is squared. The middle term, the times 2, the constant 2 is here. And then I copy the two terms, the 5x and the 2y are here. And the last term will be the 2y must be squared. And then simplify each term. So the 5x power 2 becomes 25x squared. The middle term, 2 times 5 is 10, times 2 is 20. And the xy will just include. So the middle term is 20xy plus the last term, the 2y is squared. It's now equal to 4y squared. Let's go to the second part of the square of binomial when we have a difference of two terms and it is squared. So x minus y all raised to 2. In the books, we will see that the answer is x squared minus 2xy plus y squared. Actually, we have the same idea with our first part. If you look at the first term here, the x squared, it comes from the first term of the binomial that is squared. So this is from x becomes x squared. If you look at the middle term, we simply multiply by 2 and then times the product of these two terms here. So x multiplied by negative y, you will get a negative sign. That's why you see here there is a negative sign. So negative 2xy in the middle term. And the y square actually comes when we square a negative y. Of course, we know that negative times negative will be positive. That's why here it is positive y squared. So these are the three terms when we square a binomial like this, the difference of two terms. So let us have a quick multiplication to verify our product here. So the x minus y all raised to 2, we can show that this is x minus y times x minus y. Then we will do the long method of multiplication. We distribute one term to the other terms. So you see here x times x will give us x squared. X times negative y is negative xy. Then the negative y times x can be written as negative xy also. Negative y times negative y is positive y squared. You see here the middle terms, they are like terms that we can add together. So we have x squared minus 2xy plus y squared. And that is the same product that we see on this formula on top. So we can now use this formula to solve some products of this pattern. Let's have example 1. 1 minus 2x raised to 5 all raised to 2. So we have the three terms here. The first term is the square of the number 1. In the middle, I put the constant 2. I copied the 1. I copied this 2x raised to 5. Actually, the negative sign is already in front. And the last term is the 2x raised to 5 power 2. There is no issue if you put also the negative sign here. Anyway, because of the square here, later it will just be deleted. Then we simplify each term. 1 squared, we know it is 1. So the middle term minus 2 times 2 is 4, x raised to 5, and then plus 4x raised to 10. So this is our final answer. Let's have example 2. 4x minus 3y all raised to 2. So our three terms, the 4x is squared here in the first term, and then minus. I will put my constant 2. Then I will copy the 4x is here, the 3y is here. And then plus, for the third term, the 3y is squared on the last term. And then we will simplify all the three terms. For the 4x, all raised to 2 becomes 16x squared. The middle term, 2 times 4 is 8 times 3 is 24. And then the xy are included in the middle term. And the last term is 3y all raised to 2 becomes 9y squared. So this is our final answer. We're going to study special products of cube of binomial. We're going to have two parts. The first part is the sum of two terms, and it is raised to 3. In the books, you will find the special product to be these terms. We have 4 terms in the product here. So let us examine one by one. The first is x3. It comes from the first term here, x, and it is raised to 3. The second term, the constant 3 will always be there. So we're going to multiply the x and the y. But the first term x will be squared. So you see here 3x squared y. The third term, the constant 3 is always there. Again, we're going to multiply the x and y. But this time, we will square the second term, that is y. So you see here 3x y squared. And the last term here is the cube of this y. So it is y cubed. Now let us have a quick multiplication to confirm this product. So I copied the x plus y raised to 3. And we know by long multiplication, we can write x plus y times x plus y times x plus y. And then this x plus y times x plus y, we can simplify this using our special product of square of two terms. So we can have this x squared plus 2xy plus y squared. And then the x plus y is copied here. Now we are going to again do the long multiplication. One term here will be multiplied to the terms of the other group. Another term here will be multiplied to the terms of the other group. And the last one will also be multiplied to the terms of the other group. So you see here we have x squared times x will get the x cubed. The x squared times y will get this x squared y. Let's have this 2xy multiplied by x. We'll get this 2x squared y. This 2xy multiplied by y, we'll get this 2xy squared. And the last term for the trinomial y squared times x, we have the y squared x, or we can write like this, xy squared. And then the y squared multiplied by y, we'll have this y cubed. Next, we will collect like terms and combine them. You see here, the x squared y and the 2x squared y, they are like terms. Also, the 2xy squared and the xy squared are like terms. So we can combine them. 3x squared y, also these two like terms can be written as 3xy squared. So copying the x cubed here, copying the y cubed. So we have this x cubed plus 3x squared y plus 3xy squared plus y cubed. So this is our final answer. And we can see that this answer here is the same with our special product written on top. Now we are ready to use this formula to solve problems like this. So let's have example 1. This is 2a plus 5 all raised to 3. So in the answer, we expect 4 terms. So I put here 4 blanks. So the first blank is the first term 2a, we will raise into 3. Then the second term will be the times 3. And then I'm going to copy these two terms, 2a and 5. but the 2a must be squared. The third term, again the constant 3 will be there. I am copying these two terms, but this time the number 5 will be squared. And the last blank, the 5 will be raised to 3. And then we'll just simplify the terms. So this 2a raised to 3 will give us 8a cubed. Let us first simplify the 2a squared. We will get this 4a squared. Also the 5 squared in the third term will give us 25. We can simplify the 5 cubed. It will give us the 125. Then going to the next line, the a cube is copied here. Then we simplify, we multiply these terms, 3 times 4a squared times 5. We'll get this 60a squared. And then the third term, 3 times 2a times 25 equals 150a. And we just copy the 125. So this is our final answer. Let's go to example 2. X squared plus 2y all raised to 3. So I'm going to write the 4 blanks to represent the 4 terms. In the first blank is the first term, the x squared must be raised to 3. In the second blank, there must be the constant 3. Then I'm going to copy the 2 terms, but the first term must be squared. In the third blank, again I'm going to put the constant 3, and then I'm going to copy the 2 terms here, but the second term, the 2y, must be squared. And for the last blank, the 2y must be raised to 3. And then we're going to simplify each term. For this x squared all raised to 3 will give us the x raised to 6. Now in the second term, let us first simplify the x squared and then squared. It will give us the x to the 4th. So on the third term, the 2y raised to 2 will be simplified into 4y squared. The last term, 2y raised to 3, can be simplified into 8y cubed. Now going to the next line, we will simplify further the second and the third terms respectively. So we'll just copy the x raised to 6 down here. And for the second term, we're going to multiply 3 times x raised to 4 times 2y. It will give us the 6x raised to 4y. And then for the third term, we multiply 3 times x squared times 4y squared. It will give the 12x squared y squared. And the 8y cubed, we will simply copy here. So our final answer, x raised to 6 plus 6x raised to 4y plus 12x squared y squared plus 8y cubed. Let's go now to the second part. So this is x minus y all raised to 3. Or we can say this is difference of 2 terms and raised to 3. In the books, you will find these 4 terms to be the special product. So let us examine one by one. The first term is x cubed. It comes from the x here, that is raised to 3. And then minus the constant 3 is here, and then x squared. This is the x that is squared, followed by the y. And then plus another constant 3 will be there, and then the x, that is the first term, and then the y squared. This is the y to be squared in here. And then minus the y is raised to 3 also in the last term. So take note also that in the special product, we have alternating signs from positive to negative to positive and negative. So now we're going to have a quick multiplication to confirm the special product here. So I'm going to write the x minus y down here, raised to 3. So by our long multiplication in the power of exponent, I'm going to write x minus y times x minus y times x minus y. And then I'm going to simplify the first two factors. It will give me this x squared minus 2xy plus y squared. So we can apply our special product here for the difference of two terms. So these are the three terms for the special product. And then the x minus y is copied here. And then, one by one, I'm going to take one term and multiply to the other terms of the other group. Same thing will happen to the negative 2xy, multiply to the terms of the other group, and also this term to be multiplied to the terms of the other group. So let's start with the x squared, multiply to the x, to give us this x cubed. Then x squared times negative y will give this negative x squared y. Next is this negative 2xy times x will have this negative 2x squared y. Negative 2xy times negative y will give this positive 2xy squared. Then the y squared multiplied by x will give xy squared. Then y squared times negative y will give this negative y cubed. Then let us collect like terms to be combined. You can see here, these two terms here are like. Also, these two terms are like that we can combine. So x cubed is copied. Then these two terms becomes negative 3x squared y. These two terms becomes 3xy squared. And then the negative y cubed is copied down here. So when we compare, the product here is the same with our special product written on top. There's also one idea here that this rule follows the x plus y raised to 3. Suppose we are discussing this rule. Let's have this example to be solved. So now I'm going to write the 4 blanks and then connected by the plus signs. So please follow me. The first blank, I'm going to put the x and then put the power 3. Next blank, I'll put the number 3 constant, and then the x will be squared followed by the negative y. And then plus for the third blank, for the third term, again the constant 3 will be there. I copy the x and also the negative y must be squared. On the last blank, the negative y or the second term of the binomial will be placed here and then raised to 3. Then let us simplify. The first term becomes x cubed. In the second term here, the negative sign of the y will be placed in front. So we can see it becomes negative 3x squared y. In the third term, the negative y is squared, so the negative sign will go away. It becomes positive. That's why in the third term, it becomes plus 3x y squared. In the negative y, all raised to 3, so the negative sign is raised to an odd number. It means the negative sign will stay. So this is negative y cubed. So you can see here again that the product here is the same with our special product written on top. So one conclusion can be made. If we're going to solve a difference of two terms and it is cubed, we can also use the idea of the first special product here, the idea for the x plus y raised to 3. So let us see one example. So the 10 minus 2m all raised to 3. Now I'm going to use the idea of the formula number 1. I'm going to write my 4 blanks and then connected by the plus signs. So the first blank is for the 10 raised to 3. The second blank, I'm going to write my constant 3, and then these two terms I'm going to copy here, but the first term, which is 10, must be squared. In the third blank, the constant 3 must be there. I will copy the 10 and the negative 2m, but this time the second term or the negative 2m must be squared. For the last blank, the negative 2m must be raised to 3. So let us now simplify the terms. The 10 cube becomes 1000. For the 10 square, I will simplify this first, becomes 100. The negative 2m in the third term is raised to 2. So I simplify this into 4m squared. Of course, the negative sign goes away, so it becomes positive. And the last term, the negative 2m raised to 3, becomes negative 8m cubed. And then let us simplify further. I copy the 1000 down here. For the second term, I multiply 3 times 100 times 2m. It gives 600m. Again, that is negative. And then the third term, I copy the plus sign. I multiply 3 times 10 times 4m squared. It gives 120m squared. And then the negative 8m cubed is copied here. So this is our final answer. Let's go to example number 2. 5p minus r squared all raised to 3. Again, I'm going to write my 4 blanks, representing my 4 terms. The first blank, I'm going to copy the 5p and then raise to 3. In the second blank, the constant 3 must be there, and I'm going to copy these two terms, but the first term 5p must be squared. In the third blank, the constant 3 is there, and then I copy the two terms again, but now the second term negative r squared is now squared. And the last blank, the negative r squared is raised to 3. Now let us simplify. The 5p raised to 3 equals 125p cubed. Now in here, the negative sign is placed in front. Then let us simplify this 5p squared. It becomes 25p squared. And then on the third term, we simplify this negative r squared and then squared. It becomes r raised to 4. The negative sign goes away. Now for the last term, negative r squared raised to 3, the negative sign remains because it is an odd number, and then the r is now raised to 6. So let us simplify further. The 125p cubed is copied down here. Then for the second term, the negative sign is there. I multiply 3 times 25p squared times r squared. It gives 75p squared r squared. For the third term, the positive sign is there. Then I multiply 3 times 5p times r raised to 4. It gives this 15p r raised to 4. And the negative r raised to 6 is copied down here. So this is our final answer. We're going to study special products of these forms. Two forms will be of this type, and the third special product will be of this form. Let's begin with our first type. In here, we're going to multiply binomial and trinomial of this form. In the book, you will find the special product for this to be a binomial, which is x cubed plus y cubed. So let us examine our factors here. Look at the binomial x plus y. If we look at our product, it is x cubed plus y cubed. It seems like we are simply putting the cube on each term of the binomial here, and we put in the final answer. And the same sign of positive is written in between them. It means to say we can examine our trinomial factor here. Here is x squared. This is the square of the first term of the binomial. The middle term is negative xy. This is the product of these two terms, x and y. But we should write the opposite sign. If we multiply x and y, it will give positive xy. But in here, the sign must be the opposite. Should be negative. So negative xy in the middle term. And the third term of the trinomial is y squared. And that is the square of this y here. So it is y squared. Binomial is x plus y, and the trinomial is x squared minus xy plus y squared. Your special product is simply the x cubed plus y cubed. Now let's have a quick multiplication to confirm the product of this binomial and trinomial using our long method. So I'm going to multiply the x with all the terms of the other group. Then later I will multiply the y with all the terms of this trinomial also. So it will appear like this. X times x squared, we will get the x cubed. Then x multiplied by negative xy, we will get this negative x squared y. Then x times the y squared, we will get this xy squared. Next is for the y term here of the binomial. I'm going to multiply first with the x squared. The answer is x squared y. Next is the y multiplied by negative xy. We will get this negative xy squared. And the y multiplied by y squared, we will get this positive y cubed. And from here, we're going to look for like terms. So this negative x squared y, there is a positive x squared y here. Also, this xy squared, positive, there is another term which is same literal coefficient xy squared, and this is negative. So it means to say we can cancel these terms respectively, and then we will collect the terms that will remain. Obviously, this is x cubed that will come, and also the plus y cubed. So this is our final answer. As you can see, this answer is the same with our special product that is written up here. Now we are ready to use this formula when we encounter multiplication of polynomials of this pattern. Let's have example 1. b plus 3 multiplied by b squared minus 3b plus 9. First, let us analyze each term if pattern is met. So there is no question with the binomial. We will simply check the trinomial part. Okay, so the first term here of the trinomial is b squared. It is simply the square of this b. So the first criterion is checked. The middle term, if I multiply b by 3, I will get positive 3b, but I should write the opposite sign, negative 3b. So the second criterion is checked also. What about the third? The third term is 9. So this 9 is simply the square of the number 3. So the third criterion is checked. So it means to say the pattern is met. In that case, what we will do is we're going to write here two blanks to represent our special product. In the first blank, I will copy the b, I will put in the first blank, and then put the power 3. And then I'll make sure that this is plus. And for the second blank, the 3 will be put on the blank, and then we'll put the power 3 or cube. And then we will simplify. So the b raised to 3 will be b cubed, and then the 3 cube will be 27. So this is our final answer. Let's have example 2. 2x plus 5y is the binomial, multiplied by the trinomial 4x squared minus 10xy plus 25y squared. We can rewrite the problem into same pattern of the special product. So for the 4x squared, we can rewrite this as 2x raised to 2. For the negative 10xy, we can factor this out in such a way that we can see the terms of the binomial. So the 2x and the 5y are there, and the sign must bear the opposite. So 2x and the 5y, and then the minus sign is here. And for the third term, the 25y squared, we can write as 5y all raised to 2. So we can say that the pattern is met. So what we will do now, we will go to that same problem, and then we'll put the equal sign. We will now put the two blanks to represent the two terms of the special product. Let's begin with the first blank. I will collect the 2x, and I will put the power 3. And then plus. For the second blank, the 5y is copied here, and then power 3. We will simplify further. The 2x raised to 3 is equal to 8x cubed, and the 5y raised to 3 is 125y cubed. So this is our final answer. Let's go now to the second type of special product. We have this binomial x minus y multiplied by the trinomial x squared plus xy plus y squared. In the books, you will find that the special product for this is a binomial which is equal to x cubed minus y cubed. If we look at our binomial here, it seems like we simply take the cube of this x and write here, and for the sign, if this is minus, same negative sign is coming here. And then the y is copied, and then with power 3. So we're going to analyze the trinomial. So this is x squared. This is simply the square of this x. The middle term is xy. So it seems we're multiplying the x and negative y. But we should write the opposite sign, because if I multiply x by negative y, I will get negative xy. But based on the pattern, I should write the opposite sign. So this is plus xy. And the third term of the trinomial is simply the square of this negative y. So negative y is squared, it will give positive y squared. So if a certain multiplication of binomial and trinomial falls on this category, we can simply write the final answer as a simple one. This is x cubed minus y cubed. Formula B, or special products A and B, have similar pattern. Now we are ready to see example 1. So this is ab squared minus 2 is our binomial. In the trinomial, it's written a squared b raised to 4 plus 2ab squared plus 4. And then we can rewrite the problem into same pattern of the special product. For the binomial, we simply copy. Now, for the first term of the trinomial, let us show that this is the square of the first term, ab squared. So this is ab squared, and then the power 2 is outside. If we simplify this, we will go back to our a squared b raised to 4. The next, the middle term, let us show that this middle term is the product of this binomial. So ab squared is here, and the negative 2 is here. But when we get the product of this, we should write the opposite sign. Okay, if we multiply these two, we will get a negative sign, but in the pattern, we should write the opposite sign, so this is plus. For the third term, we should show that this is the square of this second term of the binomial. So this is negative 2. If we square this, it will go back to our positive 4. So it means the pattern is met. In that case, we will go back to our problem. Then we will put now the special product. Let us write the two blanks to represent our two terms of our product. So the first blank here, we're going to copy the ab squared. We'll write here and then put the power 3. And then we should write the negative. And then for the second blank, the 2 is copied and then write the power 3. Then we will simplify now. So this term here becomes a cubed b raised to 6, and then minus the 2 cubed is 8. So our final answer is a cubed b raised to 6 minus 8. Let's have example 2. This is 5xy minus 1 multiplied by the quantity 25x squared y squared plus 5xy plus 1. So again, we will check the pattern. We will rewrite this problem and see if this pattern falls on our special factors pattern like this. So there is no issue with our binomial. We simply copy that. Now for the trinomial, we will check one by one. The first term, it must satisfy that this is the square of the first term, the 5xy. So this 5xy, if we square this, we will get back to the 25x squared y squared. So the first criterion is met. And then for the middle term, let us show that this is the product of the two terms of this binomial. So the negative 1 is here, the 5xy is here. If we multiply this, we will get a negative sign, but as a rule, we should write it as positive. So the second criterion is checked. Let's see the third. The third criterion, we should show that this 1 here is the square of the negative 1. So if this negative 1 is squared, it will go to positive. So again, the third criterion is checked. It means to say the pattern is met. In that case, we will go back to our problem. Then we will write the two blanks to represent the terms of the special product. For the first blank, I will collect the 5xy, then I will put power 3. Then followed by the negative sign, and then for the second blank, the 1, will be raised to 3. Then we'll just simplify. The 5xy raised to 3 becomes 125 x cubed y cubed, and then minus 1 cubed is 1. So this is our final answer. Let's go now to our third type, and this is square of trinomial. As you can see here, we have three terms, x plus y plus z, all raised to 2. In the book, you will find that the answer for this is 6 terms. So let us examine one by one. We can group the 6 terms into 2 groups. The first 3 is one group. The last 3 is another group. So let us examine the first 3 terms. So these 3 terms are actually the square of each of the terms of the binomial. So you see, the x is squared here, the y is squared here, and the z is squared here. For these last 3 terms, the pattern is we're going to multiply 2 terms at a time and then multiplied by 2. So you see here, the xy is multiplied together and then times 2. The x and z are multiplied together and then times 2. The y and the z are multiplied together and then times 2. And that's it. This is now our special product for the square of trinomial. Let's have a quick multiplication to confirm if this special product is actually the same answer if we're going to have a long method of multiplication for this square of trinomial. So what we'll do, we're going to expand, so we can show that this is x plus y plus z times x plus y plus z. Then we will do a long multiplication. So this variable x, I'm going to multiply to all the terms of the other group. So it will come like this. X times x will get x squared, x times y is xy, x times z is xz. Next, the y, I'm going to multiply with the x, I'll get xy. Then y times y is y squared, y times z is yz. And then plus, now the z multiplied to the x, it is xz. Z multiplied to the y, it is yz. And then z multiplied to z will give z squared. And then I'm going to remove the grouping symbol and then to combine like terms, if any. But in writing my final answer, at first, I'm going to collect all terms with squares. So this is x squared, there is y squared, there is z squared. I'll write them first in here, and then I will collect the like terms. There is an xy here, positive, there is positive xy here. So combining them, I will get the 2xy. The xz in blue color, there is another xz here in blue color. They are like terms, so we can combine them to be 2xz. Now, the other one is the yz, positive. Another positive yz is here. We can combine them together. We will get the 2yz. So, this is our final answer with 6 terms. So, these 6 terms, the final answer here is same with our special product written on top. So, it means to say, we can now use this special product to solve problems that will fall on this pattern. So let's have example 1. A plus 2b minus 5 all raised to 2. So as per our special product, we're going to square each term of this trinomial. So you see here, the a is squared. The 2b is also squared here. The negative 5 is also squared. So this comprises our first group. And for our second group, we're going to multiply two terms at a time and then multiplied by 2. So at first I'm going to multiply a and the 2b and then times 2. So you see here 2 times a times 2b. Next I'm going to multiply a and the negative 5 and then times 2. For the last term I'm going to multiply 2b and the negative 5, it's here, and then times 2. Next, I'm going to simplify now the 6 terms. So this term here becomes a square. The 2b square is 4b square. The negative 5 is squared, it becomes positive 25. For the fourth term, this 2 times a times 2b will give 4ab. For the fifth term, we multiply 2 times a times negative 5, we'll get negative 10a. For the last term, we multiply 2 times 2b times negative 5. So this is negative 20b. So for our final answer, this is a square plus 4b square plus 25 plus 4ab minus 10a minus 20b. Let's see example 2. 3x minus y square plus 10 all raised to 2. So let us use our special product. Let us square each term here. So 3x is squared. The negative y square is also squared. And the positive 10 is squared. And for the second group, I will collect two terms at a time and then multiply it by 2. So first I'm going to multiply 3x and negative y square. It's here, and then times 2. And then plus, I'll multiply 3x and the 10. It's here now, 3x times 10 and then times 2. And the last term, I'll multiply the negative y square and the 10. It's written here, and then times 2. Then we will simplify each term. The 3x raised to 2 becomes 9x squared. This negative y square and then square outside, the negative will go away. It becomes y raised to 4. The 10 square is now 100. So the first group is now complete. I'll go to the second group. For the fourth term here, I'm going to multiply 2 times 3x times negative y square. So the negative sign comes here, and then 6, and then x, and then y square. For the fifth term, I'll multiply 2 times 3x times 10. It will give 60x. And the last term, I will multiply 2 times negative y square times 10. So the answer is negative 20y squared. So we have now the 6 terms as our final answer. So this is 9x squared plus y raised to 4 plus 100 minus 6xy squared plus 60x minus 20y squared. One more point that I want to make. Since we are putting square to each term of this trinomial, it means to say the first 3 terms in the final answer must always be positive. Thank you for watching the video. See you again next time.